We are live. Okay. Graph it. Tell me the thing. Either you remember how to graph by intercepts or you're going to have to wiggle that thing around until it looks a little more familiar to you. Both options are perfectly legal. Okay. Graph it. Tell me the stuff. That's all Friday was really about. It's been 4 days, plenty of time to practice, ask questions. Remember, when you are graphing these, make as many points as possible. Use a straight edge because where they end up is very important to the solution of it. Yes?
I was gone and I watched the video and everything. So you have to get to like this, right? And you have to graph.
If you want to, you can graph it like this. Remember
Oh yeah, okay.
that kind of stuff?
But if I divide by 3, and that, how would I graph that?
You can still use your slope. It's just going to be in that spot of the box.
Okay. I don't know if I do this.
It ends up in a nice place.
Well,
You should have integer answers.
I do get a. I don't know if I did that right. I'm getting a.
Oh, if you need to do that to graph, you're good. Keep going.
Okay.
Graph it, graph it. Just be careful with your points. Okay, trust me, these will end up with a nice common point.
Just saying that. Oh.
Hmm.
I can do the. Can I do that? And
You
then.
can do that, but y will no longer be by itself. Depends what you're trying to do. Who's still going? All right. Stage one. Given the amount of red boxes in my grade book, let's make sure that we have all those devices put away and remove temptation, including the headphones in your ear that you think I don't see. Step two. Y'all remember Graphing by intercepts. Standard form, section 5.5, 2 weeks ago. If I put a 0 in for y, that'll be something on the x-axis. 4x equals 8, divide by 4. X-intercept of 2. If I put a 0 in for x, I get a y-intercept of 8 divided by 2 is 4. I have 2 points. In between those 2 points makes a slope. I can use that slope to make more points. Down 4, right 2, I can also go down 4, right 2 again, or I can reduce that to down 2, right 1. That's in the wrong spot. You get up there. There we go. So regardless, I got that line. Or maybe you rearranged it. Subtract 4, divide by 2. Did you have a y equals negative 2x plus 4? Okay. For the second one, if I graph by intercepts again, we've got an x-intercept back at negative 5, way back here, and a y-intercept at, divide by 3, 5/3. So there's 1/3, 2/3, 3/3, 4/3, 5/3. If you don't like that, you can always add x, 3y is x plus 5, divide everything by 3. Getting y is 1/3 x plus 5/3. So again, that y-intercept of 5/3, but now you got the slope to go with it. If I have a slope of 1/3, that's up 1, right 3, I can still do that even if it's in a weird spot. Because up 1 from weird spot is weird spot plus 1. Right 3 is over weird spot, over weird spot, over weird spot. It's just going to be 2/3 of the way through that box. And we've done this a bunch of times. Or I can go down 1, left 3. 1, 2, 3. I connect the dots. Not bad for not having a straight edge. And I see where those two cross. That is a solution to a system. The yellow line. I really, really want ice cream. The blue line. My wife really, really wants brownies. The purple dot. The one place in town that has brownies and ice cream, which I don't even think there is other than the grocery store around here. Do they sell brownies? I know they have them in some of the blizzards, but just learned something. So, your points should be, do you have the correct y-intercept? Do you have the correct slope? Do you have the correct y-intercept? Do you have the correct slope? Did you get the intersection? Now, for the frantic amount of writing that I saw during this, and the amount of blank graphs and blank pages as I was coming around, I remind you yet again, getting a 4 out of 5, a 5 out of 5 on every daily quiz does not move the needle. Having perfect daily quizzes over the course of the entire semester compared to the real score that you had is going to be the difference of maybe 2%. Maybe. Actually, using this to gut check, to say, wow, I don't know how to do any of that. I should probably come ask questions. I should probably get some extra practice. I should probably go back and watch our lesson videos from the classes that I skipped or didn't watch or just spaced out in. It's the gut check to say, I need to know this better, I should do something about that. Okay? Now I will say kudos to the handful of you who asked questions. There were a handful of you that actually asked questions. So good on you. From the homework. Yes, sir?
29.
29. Words or fractions, right? That's how it always ends up. Words or fractions. Fractions. Okay. Solve each system by graphing. Determine whether it has one solution, infinitely many solutions, or no solution. Before I do that, tell me what those mean. If I graph things, what does one, infinite, or no solution look like?
Definite many solutions are lines overlapping each other.
Okay. Same line. What about no solution? Parallel lines. Never going to cross. One solution. They actually cross, and you tell me where. So if I'm going to graph these two lines, the thing I should probably do is make them look like equations you can graph. If you don't like this, because that doesn't look like anything you normally graph, then let's change them. Oh, 29, there we go. So if I have 2y is x minus 2, I'll divide everything by 2. And get y is, what invisible number is in front of that x? So I call it 1/2 x. And 2 over 2 is 1. I'll get this one by itself as well. Divide everything by 3. 3/2 over 3. Ew. It's called a compound fraction when you have a fraction that involves a fraction. But dividing by fractions is easy as pie. Flip second multiply. That also applies to whole numbers. If I take 3/2 divided by 3, it's the same as multiplying by 1/3. Flip it and multiply. But those cancel and I get 1/2. So it turns out this is, and that's 1, so I get y is 1/2 x minus 1. So when I go to graph those two, I'm just going to quick graph. Don't do this for your assignment. Okay, graph them for real. I'm going to have a y-intercept of -1, up 1 over 1, 2, or down 1, back 2. Well, that's the first line. Go to graph the second line, you're like, wait a second, it's the same thing. And you just said it. If there are two lines right smack on top of each other, I would say there are infinitely many solutions. Everything on that line is going to be a solution.
So I got an infinite many solutions except mine flipped to the other side.
Okay, so we need practice on our slope, and that's why every time we have these slopes, all throughout chapter 5, I kept writing, if I have a slope of 1/2, remember the whole rise, run thing?
Yeah.
We always go to the right. If it's negative, we go down. If it's positive, we go up. Since this is a positive 1, I know I headed up 1. Right 2. Putting those arrows next to your slope will really, I'm not joking. I have my inclusion algebra class is my Maroon 3 class, and I force that. I make them put that next to every single one of their graphs, and there are kids who got through algebra half last year that could not graph a line to save their life. As soon as I started forcing that, I've got kids now who say, like, they yell at me for not putting my arrows next to stuff because that's the only thing that makes it make sense for them. Kind of like when we're solving equations, how many of you need to have some sort of divider line right here? Otherwise, you keep putting the wrong thing on the wrong spot. Okay, make it lopsided. You know, you took one kid off of this side of the teeter-totter, you took another kid off of this side of the teeter-totter. It doesn't work, right? Those little tips and tricks, they're there for a reason. Speaking of, just while I'm thinking of this, so I got one of the algebra half sections. Scoglin has 4 or 5. I just had the leftovers today. Well, you're not leftovers, okay? Leftovers can be good. Anyway, we had a big meeting earlier, or was it last week, with a couple of the math teachers, all of our special ed case managers, our 504 accommodation coordinator, our counselors, administrators. We got a whole big gaggle of people together to try to figure out what we're going to do with inclusion algebra next year. So I'll just let you know, a couple of you, your names popped up. We just kind of talked about past performance, current performance, that kind of stuff. So for some of you, if you find like algebra half, you're really struggling, then we have a different option than just going to algebra 1 next year. It's called inclusion algebra 1, and it's kind of like algebra 0.7, where either our skills are shaky and we need a little bit more direct individual instruction. I run that class with no homework at all. We do every single scrap of it in class together. 9 times out of 10, I've got 1 or 2 other teachers in here with me, and it's like 2 or 3 of us against 15 kids. Small group, you get the help you need. We solidify the living snot out of everything from algebra half and then sprinkle in what you absolutely need from algebra 1 to move on to our inclusion geometry. And after you have those 2, then as a junior, you would go to our business math class. And then you get your diploma and you get the hell out of here. If that's your jam, if you just say, I just want my piece of paper, let me out of this building. Okay? Or I want to go to a tech school. I want to go to a 4-year school, but math is really tough. That class is specifically designed for kids who just have a rough time with math. Okay? It's an instructor permission only class. Normally you would just talk to the counselors, or if you have a case manager, or your current instructor and say, hey, is that a thing that I can do? And heck yeah, stop on down. You don't have a book to carry around. We do everything just in packets. We take as much time as you need. If it takes 1 day to do a concept or 5 days to do a concept, we just don't move on until you get it. So just let you know, that's an option. And in that class, we slow down and we are doing like beat the living crap out of that and make sure that you understand it, because that's the bare minimum you need to graduate. So kind of tossing that idea out there, because there were a couple of you where I know you're really trying, and maybe it's just not working right now. You need to try something different. Y'all heard the phrase, doing the same thing over and over, expecting a different result. Definition of insanity. Okay? If you feel like you're just banging your head against a concrete wall right now, come have a talk with me. Okay? I'll switch you over to that class for next year, and it actually does really good. And it does qualify as your Algebra 1 for graduation. Okay? So, if anyone's at jam. Any other fractions or words in here? Yes, ma'am. Sorry, I just, tangent. 15. ADHD, go brrr. Okay, 15, same thing. Graph it, check solution. Okay. So, just like the one Dominic asked, it don't look right. So if it doesn't look right, make it look right. I have 4x minus y is negative 1. In order to get that y by itself, subtract 4x. And maybe this is where I need to slow down and start showing these steps more and more. if you actually put your 0 there, if you say 4x minus 4x, like we did back in first semester, then you'll catch that it's a negative y that's left over, and a negative 4x minus 1. That's what tells you you're not done. You have to multiply this whole honkin' thing by a negative 1 to get y actually by itself. And that might be the problem, is our line just had the wrong slope and the wrong y-intercept, and it went in the wrong direction. Okay? It ended up being that kid, and you all know that kid. You've probably been that kid who comes up to the door that says push, and you're sitting there thunk, 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 pulling on it. Okay? It just went the wrong way. Do the same thing over here. This one's a little bit quicker though, where I just add x, zeros out, and I have y is 2x minus 5. So we graph these two, 4x plus 1 and 2x minus 5. See if short-term memory can get that. Did we? 2x minus 5 plus 1. Jeez. Wow. There we go. So, purple line. I don't even know if these are going to fit on this graph. This is a very small graph. It only goes 5 in each direction. I might need to change my scale on it to fit this. But I'm just going to go for it right now. Actually, I'm sorry. 5, 3, 5. Okay, it should. Start at 1. Slope is up 4, and if you need to write that, if my slope is 4, write it as a fraction. It's positive, so I go up and right. Up, 1, 2, 3, 4, over 1. Or, if you're putting those arrows on there, it also helps you to say what goes backwards. Down 4, left 1. 1, 2, 3, 4, left 1. So this one's really tall and skinny. Beanpole, don't worry, you'll flush out. Okay, the other one, I start way down here at negative 5. And I got a slope of 2. It's positive, so up and to the right, we go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, or down to the, See, I didn't have enough room to actually see the rest of the graph. This is where on your graph paper, if you're actually using it, I'd recommend kind of starting with a 10 by 10 grid instead of little ones like this. So I'm going to have to alter my graph here. I'm going to have to go by 2s. Say this by 2s. Start at 1. Slope is 4. Up to 4 over 1. Up to 4 over 1. Down to 4 over 1. Down to 4 over 1. Down to 4 over 1. And start negative 5, 2, 4, 5. Slope is 2. Up 2 over 1. Up 2 over 1. Up 2 over 1. Or down 2, back 1. Down 2, back 1. Down 2, back 1. Barely. It was off-road, but I saw it. So even going by 2s, man, I didn't even hit the last point. That was bad. Even going by 2s, I barely saw it. And I think this was, Amy was asking me about this at the beginning of class. We had one where, I know they're going to meet, I just can't see it. You got to make a bigger graph. So way back here at negative 1, 2, 3, down 2, 4, 6, 8, 10, down another box, right? Pretty sure that's another box. So negative 3, negative 10, or negative 12. But next to every one of these, it said, check your answer. That's the catch. See, I had to go off-road for my graph. Maybe you kind of BS'd your points, and your line doesn't look the nicest. You think it's here, next to it, it says, check your answer. I should be able to put in here Negative 12 for y is 4 by negative 3 plus 1. Is that a true statement? No. Think it was actually negative 11. It's just my graph was off. So I had to go off-road.
Yeah, it's negative 11.
Okay, so try that instead. Negative 12 plus 1. Yep, it works. Try again. Negative 11 is that 2 by negative 3 plus 1. Negative 6 plus 1, negative 11. That ain't work. That's a 5. Wow. That's a minus 5. Wow. Y'all got to be faster because you could have just had like 3 brownie points in a row. Negative 6 minus 5 is negative 11. Huh. When you're graphing, A, as many points as possible. B, straight edge. C, graph paper. Some of you are still trying to BS this on regular notebook paper. Get graph paper. And even then, this goes into today's, okay? Because again, I had Dominic and Amy both asking questions and both lamenting about how much they hate graphing. Sometimes we do all the work right, and the points end up, or the lines end up crossing in the dumbest spot ever. It doesn't even look like a normal number. What happens when I do all that work and then my lines end up crossing there? And you double and triple checked it. No, my lines are perfect. Well, what is that? What coordinate is that? Something icky. Is that negative 1.5, positive 1.7? Is that negative square root of 2, square root of 3? You don't know, do you? Because it doesn't land on a nice integer intersection. So what if I don't want to graph? Or what if the graphing doesn't get me close enough? That's what 6.2 is. So if you liked the solving equation part of first semester where all you did was just move around letters and numbers, I can do that. Let me do that all day long. Then you're going to like this. Okay? Start it the way we always do. Here's a little thought exercise. Answer the question. Apparently they're playing a game of Monopoly. We can't say the other word so we don't get sued. But wink, wink, they've got a bunch of hotels and cars and houses. They want to know how much is each worth. Can you figure this out? How much is each worth? Do another one after that. Think about it. If this and this and this and this is a hotel, then they have two hotels, or sorry, what is that? Two houses. This and this and this and this makes a house. Two houses and some stuff makes a hotel. What's the hotel or the car or the house worth? Maybe? What do you think? Yeah, worst case scenario, we're wrong and we learned something. Okay? I hear car 300, house 1,000. What do you think? Well, 1,000, 1,000, that's 2,000. 300 plus 100 is 400. They said hotel is 2,400. So that would work. Does it match with up here? If I say that this is 1,000 and this is 1,000 and this is 300, does 300, 300, 300 plus 100 make 1,000? Okay, it did. How'd you do that? Oh, okay, so kind of a guess and check and then adjust your answer. Anyone have something a little more systematic? Yeah?
I took out the 100 from the 2,400, and then I kind of just put two and two together that there's an 1,000 each for the houses.
Okay. So a little bit of adjust the proportion or the equation and then guess and check. Check this out. What if I wrote that instead as star, 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 triangle, 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 and go almost PlayStation style on it. What I can do, if I know that all of this makes one of those triangles, if I know all of this made one of those houses, could I replace each of these and say now, instead of a triangle that's 1, 2, 3 stars and 100, instead of a triangle that's 1, 2, 3 stars and 100, plus my other star here, plus my other 100 here, and then they tell you that hotel is worth 2,400. If this stuff is a triangle, then how about I replace each of those triangles with all that stuff? Make sense? So now I have 1, 2, 3, 4, 5, 6, 7 of unknown plus 300 is 2,400. Solve the equation. Subtract 300, divide by 7, x is 300. Each of those stars, or each of the cars, was 300. I want you to use that idea again, that if this stuff equals thing, I can replace thing with this stuff. Try it again. This is when we introduced 3 variable systems in Algebra 2, but I think you can still do it. If this stuff equals thing, I can replace thing with this stuff. Can you tell me how much each of those boxes weigh?
This is in our packet.
Nope. I want to see if you can take that idea again. If thing equals this stuff, I can replace thing with this stuff.
So they're all supposed to be equivalent to each other.
Yep, they're balanced. 2 of the A boxes balances with a B box. Yep. Count.
I know, but like how much?
Oh, it's 10 pounds. No, that's fair. Especially from the back row. Especially the ocularly challenged from the back row. Okay. Okay. This is how we introduce even 3 variable system. This is literally from the section, 3 variable systems in Algebra 2. This is how we first introduce it. Okay, when you come back next year for Algebra 1, they're actually going to start you with systems again, because it's a really good way to review all of your stuff about lines and coordinates and algebraic manipulation. And then they'll jump into exponents, which I think we might actually get to ourselves. Get it figured out? What do you think?
C equals 6 and B equals 4.
Okay. It's 3 of the 4 numbers that cheerleaders know. Okay? How?
No, I don't.
Oh, okay. Good talk. See, if B is 2 A's, how about I just get rid of this and say that's 2 A's? If C is 3 A's, how about I get rid of C and say that's 3 A's? Then altogether, 5 A's is 10 pounds. A is 2 pounds. If A is 2 pounds, B is 4. If A is 2 pounds, C is 6. What we're doing here is called substitution. Think about when your teacher is gone. They don't just let you roam the halls. They don't just set you a free-range chicken style down the hallway and just see what happens. There's a substitute. There's a replacement for. That's what we're doing here for those of us, Amy, who hate graphing. Solving by substitution says, if I know that y is this stuff, how about I just replace y with this stuff? And it's not difficult at all. If y is this stuff, replace y with that stuff. So now it's not x plus y, it's x plus 3x is negative 32. If y is this stuff, replace y with this stuff. And now you solve the equations like we're back in first semester. Put your line down the middle if you need it. Combine like terms. Divide everything by 4. Getting x is negative 8. Now the catch to this is that we're pretty well trained by now. When you hit x equals negative 8, you're like, mic drop, I'm done.
Wait, I'm sorry. Where did you get the 4x from?
1x's plus 3x's is 4x's.
Oh,
Okay? When you dump one guy first semester and dump 3 guys second semester, you now have 4x's. Okay?
oh, that's a really good
No, it's not. It's dad joke territory. It's bad. We are so trained to say x equals negative 8, we're done. Well, you have to remember what we're doing here is saying, where are these 2 lines going to cross? Well, this line, y equals 3x, and this line is like, yeah, that. Oh, negative 32. Wrong way. Yeah, there we go. That's better. These 2 lines are going to cross at a coordinate, and every coordinate has an x and a y. So to continue the analogy, when we're solving by substitution, if you have an X, you better find out why. So, if you just discovered that your X is -8, what could I do to find the Y?
You put -8 plus y and mine. No.
I have the choice. You're right. You can plug it in either one of them. I can say X plus Y is -32, or I can say Y is 3 by X. In both cases, we said -8. All right. Here, I'll add 8 to both sides, getting Y is -24. Over here, 3 by -8 is -24. In both cases, I got Y was -24. So, if you have an X, find out Y. You can Facebook stalk them or you can ask them. Either way, you're going to find out why. Okay? So at the end of this, we're going to write our answer. Our answer is still a coordinate. -8, -24. That's where these two lines would have crossed if I graphed them. I want you to think about that. Down at -24, did you really want to graph that? Did you really want to have a graph that went out to -10 and then you graph it and you're like, ah, crap, I can't find where they meet? And so then you make a bigger graph and you go out to -20 and you go to cross, ah, crap, they don't meet. Do you want to do that graph 2, 3, 4 times, changing your scale until you can see where they meet? Or I just say, Y is stuff, replace Y with stuff. Okay, so next to this, I want you to write our steps. Step 1. Actually, for the time being, I'm actually going to call it step 2. We'll come back and fill in step 1 later, because sometimes we have to do some extra work. So step 2 is to replace a variable. I solve for one of them, and then I have to loop back and solve by plugging in whatever you just found. Solve for the other. There we go. Okay. So step 1, I said if Y is this stuff, I replace Y. Step 2, I'm going to solve this equation for X. Step 3, if I have X, I find out Y. If I know Y, I go find out X. Whichever one you have, go solve for the other one. And whether we asked them or Facebook stalked, you found out Y. So it doesn't matter which equation you plug it back into, you should get the same answer. So I'll ask you, which equation looks easier to plug X back into? Right? Because it just straight to answer. In fact, that was called direct variation back in the very beginning of chapter 5. Direct variation, directly to answer. I know X, plug it in there, Y equals stuff times X. So I said Y equals 3 by -8, getting Y was -24. Then step 5 is please write it as a coordinate. Write it as a coordinate. The coordinate is the X and Y where these two would have crossed. I'm really zoomed in here. Does it say check your answer too? No, the bottom one does. Okay, when you check your answer, you got to plug it into both of them. Because remember, it might work for one of the lines, but not the other line. That'd be like, wife wants Mexican food, I hate Mexican food, and I say, oh, that's okay, we'll go to the new Mexican joint that opened in Sturgis. And then we go there, and it turns out they don't have the gringo menu on the back. I'm screwed. She's happy. I don't get my gringo food. I don't get my chicken sandwich. So it might work for one of the lines because it's actually a solution for the line. You have to make sure that it works for both. So those 5 steps, step number 1 is a mystery, comes next. What is the solution for this system? If I say y equals this stuff, replace y with that stuff. Go solve for one of the variables, plug it back in to solve for the other. Oh, and please, 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 please use parentheses when you're plugging stuff in. And as we go further through this section, you're going to see why that's important.
What do I do with this 7?
I don't know, you didn't say y equals 2x, you said y equals all of this.
Oh.
So replace that y with all of this.
Thank you.
Mm-hmm. Yeah, when I say y equals stuff, sometimes stuff is a big long chain of junk. It all replaces y. There we go. Okay. If y is all of this stuff, then I will replace y with all of this stuff. 2x plus 7 is x minus 1. And now we're back in first semester. So, you show whatever you need to show, you use whatever tricks you need to do. Step 1. There's a variable, okay, step 1 would be to make sure that you can actually, can I combine anything? On the right side, are there like terms? On the left side, are there like terms? No. There's no parentheses to distribute. Don't have to worry about any of that. So I've got a variable and a constant on both sides. Coach says, I don't care what you move, just move something. Okay. Who was in football or basketball? No. I don't care what you move, just move something. I don't care who you block, just get in someone's way. Okay. I don't care what you move, so out of those 4 things, Preston, who's eyeballing you funny? Who do you just not like and you want them to move? Okay. So how do I undo plus 7? Okay. 0 it out to show that it's actually 0. That'll keep your signs all good. We have 2x, x, -1, -7. They go together. -8. And then you play the who's lonely game. Who's lonely? Who's all by themselves? 2x. He's lonely because he's lazy. You bring him a date, or else he's going to live in his mom's basement arguing with people on Reddit for the rest of his life. Okay? I got to subtract x. I have to bring an x over there because 2x and x go together. They're the same kind of critter. If he's lonely, Don't bring him a canoe. Like, what am I going to do with a canoe? You bring him another person. Okay? X's go with X's. I say x minus x cancels out. See, when I put that 0 over it, for those of you who weren't in here last semester, okay, I know every teacher does it different. I like to put that on there because it shows me that this is a negative 8. The sign stays with it. And 2x's minus an x is only 1x. I just said x is negative 8. Again, I got to now choose which of those two equations do I want to put that negative 8 in. Which one looks easier to deal with? Probably the bottom one. It's got less stuff, right? So I'll say y is an x minus 1. I just said that x was negative 8. So negative 8 minus 1 is negative 9. Make sure you finish it off. Write the coordinate xy. Negative 8, negative 9. If I were to graph these two equations, they would cross at the line negative 8, negative 9, or at the point negative 8, negative 9. All right. So when I said, here's your steps, we'll get to step 1. Sometimes they don't just come out and tell me y equals stuff. They don't come out and tell me x equals stuff. So you have to do a little bit of side work. Okay? There isn't an x or a y by itself. Can you make one of the x's or y's by itself? Hey, you've been doing it with all of these lines we're graphing for how many weeks now? But the question is, which one's easiest to get by itself? Top or bottom, x or y? Which one looks the easiest to get by itself? Out of any of those? I would probably aim for the y on the bottom. Now, just to show you, don't write this. 3y plus 4x is 14. If I want that y by itself, I'd have to subtract 4x, divide by 3. You got fractions. I know that this would work. You can do this. But I know how much y'all love fractions. Okay, if I want that x by itself, 3y plus 4x is 14. Get that x by itself. Subtract 3y, divide everything by 4. Again, I end up with fractions. I don't wanna. If I try to get that x by itself, negative 2x plus y is negative 3. I subtract y, divide everything by negative 2, I get x is 1/2 y plus 3/2. Again, there's fractions everywhere. It's gross. But if I get something by itself that already has a coefficient of 1, y'all learned about the animal kingdom. The lion stalking the herd doesn't go for the big alpha water buffalo. They take down the weak and the sick. They take down the little baby or the stumbling grandma at the back of the herd because it's less effort. This is less effort. It's got a coefficient of 1. It's very easy to get that by itself. So I'll add 2x and just straight up get y is 2x minus 3. Look at how much easier it is. Okay? There's no pride in doing it the hard way. Now, right next to this, I want you to put a note. This is where your big highlighter comes out, and this is super important. Never put an equation back into itself. Never put an equation back into itself. Okay? Don't write this part. I'm just going to show you why. If I say negative 2x plus y is negative 3, and I just said y is this stuff, look at what happens. Negative 2x plus 2x, gone. Negative 3 equals negative 3. Do you remember what that was called from first semester? They are equivalent. The answer would have been all real numbers because everything works. We called it an identity. Sailor, what's your name? It's almost like that's your identity, right? The input is the output. You can't put an equation back into itself or it's always going to say yes. So please put a note next to this. Never put an equation back into itself. If you rearranged the second equation, then you better put this stuff into the first equation. Otherwise, it's going to come out as an identity every time. Because you're essentially asking the question, when is this line on this line? You're like, always? It's itself? So I'll say 3y plus 4x is 14. Notice I'm leaving a nice big space for where the y stuff goes. I'll put my little divider line there because I know some of us like it. We said y is this stuff. I will replace y with this stuff, 2x minus 3. And now it's just an equation to solve. We're back in first semester. What's the first step to solving this? Disturbert. Whoop, whoop. 3 times 2x is 6x. 3 times negative 3 is negative 9. Plus 4x is 14. Do I see any like terms on that side? Put them together. 6x's and 4x's is 10x's. And then play the who's lonely game. 14, all by himself. So we'll add 9 over. Bring him a date. We're going to live in his mom's basement until he's 40. Zero that out and show that 10x is now 25. Uh-oh. I did a dumb? 23? Still an uh-oh. Because what happens when I divide by 10? You just get that. 23 tenths. Can I simplify that? 23 and 10 have a factor in common? Yes, it is. Okay. You have an x. Better find out why. Go all the way back to the beginning. And we said y is 2 times a thing. Actually, before I even write that, which one should I plug it into? Which one looks easier? Top one, bottom one, or our rearranged one? Okay. Well, you do get that choice. You get to put it wherever you want to. So 2 parenthesis minus 3. And I just said that x was this stuff. So I will put stuff. Now, if you have a calculator that'll do the fraction stuff for you, that's cool. If you got the mental mojo and you remember how fractions work, divide by 2, multiply straight across. That's y is 23/5 minus 3. If you remember how fractions work, you can either just take 23/5 minus 3 in your calculator, or times 5 times 5, turning that into 23/5 minus 15/5 is 8/5. Look at where this coordinate ended up. Just somewhere but ugly. My solution ended up as 23/10, 8/5. Were you going to guess those numbers when those two lines crossed? Never. No way. You're not going to get to the ugly answers if they don't land in a nice spot on your graph. Substitution allows me to do that. So look at your steps. Step 1. Get an equation, get y or x by itself. Step 2. Plug it in. Substitute for whatever you just found. Step 3. Solve for one of the variables. Step 4. Yellow? All right. Is you plug in x to solve. And finally, step 5. Once you solve, you got your answer. Okay? Now that's a lot of moving parts. It's also why we review with this at the beginning of Algebra 1. It's good practice. I ask you the question, are you okay to try that again? Are you okay to try that now? Or do you want to see it again to be safe? Okay. Just so we're all kind of on the same page, take a look at your system. What should you probably get by itself? X on the bottom. Okay. So get the x on the bottom by itself. And once x is this junk, replace x with this junk. Okay, not gonna lie, this is some heavy duty stuff. It's not nuclear yet, but it's still some pretty big boom. Get x by itself. If x is this stuff, replace x with stuff. I told you last time, they'll often have a system as two equations or more that are grouped together with that little squiggly bracket. Remember, it's not enough to just solve for x, not enough to just solve for y. X is stuff. Replace x with stuff. Use parentheses. What's that? -6, -6, -18, -13, -6, 42. Ew.
Ew. I agree.
Ew? -6, -6, -5, -13, -6, 42. 42, 8, 50, 50, -50 13ths. Oh. Okay, that was dumb. Flop, flop. -2, -2. -3. -2, -2. That's 3x. 2 is 14. 2 is 11. That's better. That's better. I went cross-eyed and didn't realize that they were written in different order. They do come out clean. They're integers, no fractions.
What? Excuse me? I already got my answer.
Hmm?
I already got my answer. Do we only have to find y, or can we also find x over -1? Yes.
If x is this stuff, you take this and you plug it up here for x.
Okay.
Use parentheses so you distribute the 5 into it.
That's right.
Okay. Yes, yes. Plug in, yes. Where'd this extra negative come from?
It's a minus.
Yeah, but positive 5 times -3y is just -15y.
Okay.
Okay. We said that we were going to get x by itself. So x is -3y minus 7. 6y plus 5x's is 8. We just said x is this stuff. So replace x with that stuff. Cool?
Yeah.
All right. Then, get my green back here. We disturb it. Call it 6y minus 15y minus 35 is 8. Some of us are already starting to twitch because that line isn't there. That line helps me to not goof things. Like how many kids, I've seen so many kids that will come along and say plus 15y plus 15y.
The 6, can you just drop that plus? The 6
Drop
plus 5.
plus. Oh, because it's a positive 5 times a negative 3y. That's what gets the negative 15y, or minus 15y. What?
I had the same answer.
Oh, okay.
I did right. Because I
Well, I also did it in my head, and by white 4, I'm fried. I might have screwed up. Any of those go together? So what's 6y's minus 15y's? 6y's minus 15y's? Negative 9y minus 35. If she's mad, don't point it out. She's going to hit you.
Oh, I mean, that's right.
Okay. I don't care what you move, just move something. Or in this case, play the Who's Lonely game, because there's only an 8 on that side. I add 35 to both sides. Zeroes out. Negative 9y is now, 43. Ew. Divide.
You said it's going to be clean. I was like,
Oh.
No.
Negative 2, negative 2, negative 2, 3, negative 2, 14, 14,
Okay, that's what I was
8. It's 22 divided by 2 is 11. Did I do something up here?
No, right. You did it right.
You're doing it right. Right. Because if you were.
Then my mental math is wrong. Negative times a negative 2 times a negative 2 times a negative 2.
It does not come out finished.
14 and... What's 14 plus 8? Right? Oh, divided by 3, not 2. Never mind. We're good. Negative 43 ninths. Ew. Grab a calculator. Because he can no longer be trusted. Negative 43 ninths for a y minus 7. Ew. Negatives cancel. 3/3, 43 thirds minus 7. 7, 3, 21, negative 64 thirds.
No.
See, he can't be trusted anymore. Oh, yeah, because he subtracted. See, he can't be trusted anymore. It's too close to the end of the day. We just can't do it anymore. Yeah, at this point, I just hate myself. You said 23 thirds?
Yes.
Okay.
No, 22. It's 22. It's 22.
Yeah.
You just no, you just confirmed that. I said 23 thirds. Like, that's how the list of shames started years ago. Was I had a kid who argued all the time, but she argued for the wrong answer, and then other kids would say, "Is that a brownie point now?" Because she was messing with my head the whole time. All right, so we got at least 2 there, right? If not more, earn it.
That was like 5.
That was like 3 or so.
It domino affected. It domino affected. Okay.
I think that was 3 because we stood up.
Did you write your coordinate? 22 thirds negative 40. What was it? 40 something ninths? Ew. Okay, yeah, I'll just give you the other one. Let's do that again and hope they're not gross. We're actually going to skip ahead a slide. Skip ahead a slide. We're going to do one that comes out decent. Negative 2, 1. Okay, that's actually nice. Let's do 6. Get something by itself. blame that on the book for having real crap example problems. You're supposed to put nice problems on there when kids are first learning it. So,
If I were to do the bottom one, could I just divide the 4?
but you have to divide all of them by 4.
Not about the 4y divided by 4y.
Uh-huh. But when you divide one thing, you divide all things. Math is communist. So you'd have to divide 3x by 4 as well. All of the terms get divided by 4 because you divide both sides by 4. Okay, what we're trying to get away with is you're saying, can I just do this? And I'm done. No, because this guy was left out of it. You have to divide all of them by 4.
Can I still do that?
Yeah. Except now you have a fraction. And as we just established, fractions sometimes go awry.
Why can I not do 4y?
Because now this is 1, and now you have a 4y on the denominator. Easier to just subtract 2x and get this guy by himself. So you can get the y by itself. You can divide by the 4y, but now you're into rational function territory, and it gets kind of icky.
Which equation would I use to put that one into?
Either one now. You can't put variable stuff into itself. But once you get a number, you can put that wherever you want.
Okay.
Mm-hmm.
Just to write it on the board.
Hey, throw me that bus.
You literally said you wanted to write it on the board.
All right. I don't trust myself anymore. Have at it.
Oh no. You do it.
Okay. Is everyone cool with subtract 2y? You can get the other stuff by itself, but this is the easiest route. Take the path of least resistance. So I get x is negative 2y. Cool? If x is negative 2y, then 3 times a thing plus 4y is 4. If I say x is this stuff, replace x with that stuff. Multiply, negative 6y plus 4y. Stop it! Ding, 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 ding. Combine.
Attention everyone for a quick announcement.
Divide.
A number of you received word from the district office that it is very slick out. So everybody needs to be very careful. Having reported numerous accidents around town. Due to that as well, all practices and activities have been canceled for tonight. The jazz concert scheduled for tonight will be postponed to a future date. All other practices and events going on have been and will be canceled.
Dude, I just don't
Your
want
coach, before you leave, if you have any questions, if there's anything you need to do, or your directors, but no practices after school tonight. Drive safe on the way home.
I don't know. I really don't know. It depends on whether stuff melts off or not. It depends on the wind or not. We're not going to get enough snow accumulation to warrant a snow day, but if the roads are covered in ice and if hazardous travel is around the area, then they might. So, given that announcement, I will probably call it off and go get my kid and go home. So, did you put that thing in that spot? Yay, nay, maybe, possibly, could be, chance of.
Yeah, maybe.
Okay.
if you wanna get-
Yep, totally agree. Just a negative there.
I'm very scared to drive home.
Okay.
I don't like.
Y'all, especially for freshmen who are driving, who have probably not had a ton of experience on it. Whenever you would normally slow down, you should have slowed down 3 times further than that. If you're thinking, I need to slow down now, you're already too late. Okay? Slow down. Slow press of the brakes. If you stomp on them, you are going to lock it up and you're going to slide right into them. Tell you what,